Today we will be looking at section 1 on functions and their graphs. Some of the topics that we'll include in this section are graphing equations, using point-by-point plotting, using the graphing calculator, looking at the definition of a function and its domain and range, as well as using function notation and applications of all of those. It is important to be comfortable with the Cartesian coordinate system. So I want to take a look here. You've got your x-axis, so you definitely should know where the x-axis is. The y-axis, the y always goes to the sky, so that will be our y-axis. If we have two positive coordinates, that's going to be in the first quadrant. So our quadrants are numbered starting here. So the upper right quadrant is quadrant 1, and then it goes counterclockwise. So we have 2, 3, and 4. So in the third quadrant, both the x and the y coordinates are both negative. The second quadrant, it's a negative and then a positive. And in the fourth quadrant, it's a positive and then a negative, because we always have our x coordinate first and then our y coordinate. Okay, we can have, when we're graphing these, we can have special types of lines. One of those special types of lines would be a vertical line. So a vertical line is going to be designated with x equals -4. So basically what that's saying is there's a vertical line drawn where x is -4, because if you look at all the points along this line, they all have an x coordinate. Sorry, they all have an x coordinate that's -4. They'll have different y coordinates, but they all have an x coordinate that's -4. Same thing with a horizontal line. All horizontal lines start y equals, and that just means that every point on that horizontal line is going to be have the exact same y value. So every point here, if I was to write the ordered pairs for each of these points that I'm listing, they would all have a y coordinate of 6. So like this would be the point here, that would be 1/6, and then we would have 2/6 would be the next point, and then 3/6, 4/6, and so forth. But they all have a y coordinate of 6, and that's because the equation is y equals 6. Okay, so what's really important with math is the correspondence that occurs between two different variables, basically. And one of those allows us, and that's what allows us to talk about mathematical functions. So correspondence might be like every item in a store corresponds to a particular price. Each university student has a particular grade point average. Every circle has a circumference. For each number, there's the cube of the number. Each day there's a maximum temperature. So there's a correspondence between two different things there. And functions is what kind of helps us to describe that correspondence between those. So if we're looking here, the definition of a function is a correspondence between two sets of elements such that each element in the first set, so that to each element in the first set, there corresponds one and only one element in the second set. And basically what that's saying is that we can't have one element in the first set assigned to two things in the second set. And you'll see what I'm talking about in a minute. Okay, the first set, that these kind of are your input values, so to speak, and those refer to the domain of the function. And then the output is the second set, and that's called the range of the function. Okay, so if we look at one like this, each x coordinate is paired with one y coordinate over here, or each domain is paired with one and only one range value. So because of that, this would be a function because it does satisfy the definition of a function. If you're ever not sure, write these as ordered pairs. So like -2 corresponds with -8, -1 corresponds with -1, 0 with 0, 1 with 1, and 2 with 8. And as long as these x's don't repeat, we don't have any repetition of our x values, then that means it is a function. Okay, if we look at one like this one's all kind of crisscrossed up. So again, I think writing it as an ordered pair simplifies this. So if we look at -2, -2 goes to 4, -1 goes to 1, 0 goes to 0, 1 goes to 1, and 2 goes to 4. So even though there are two x coordinates that are going to the same y coordinate, that's okay. We just can't have a repetition of any of the x's, and all of our x's are different here. So this would, in fact, be a function. Okay, looking at this one, if we start out and write our ordered pairs, the first one would be 0, 0, and then we're going to have 1, 1, but then 1 also goes to -1, and then we have 4, 4 goes to 2, but it also goes to -2. So what you can see there is, sorry, okay, what you can see there is that we do have our x's repeating. So we have two ones, and we again have two fours, and then we would have had two nines if we continued. So because the x's repeat, it is not going to be a function because one x is being assigned to two different y values, and you can't have that happen. All right, so looking at this, sometimes you'll be asked to determine if if an equation is a function simply by looking at the equation of it. So the easiest thing to do with that is to try to solve it for the y and see if you can solve it for the y without having to take an even root. Okay, so like on this one, if I wanted to get the y by itself, the only thing I'd need to do is to move that x squared to the other side, which means adding x squared to both sides. So I'm going to have 5 plus x squared. Okay, so I didn't have to take a square root. And if I don't have to take any kind of even root, then that means it is a function. Okay. If I had to take a square root, a fourth root, a sixth root to do that, to get the y by itself, then it would not be a function. So the values that we would put in for the x, those would be the domain or the input, and the values that would come out of it would be the range or the output. All right, so when I put up practice problems, I would suggest that you pause and try them, but it's up to you at this point. So I'm going to go ahead through them, but if you would like to try them first, then please do so. On one like this, to determine if it's a function, we need to get the y by itself. So I'm going to move this x to the fourth to the other side. So it's going to become a positive when I move it to the other side. And then I am going to need, in order to cancel that square, I'm going to have to take the square root. Okay, so hopefully you remember when you take a square root, you actually have both a positive and a negative case that comes from that. So for every x that I put into this, I get two different y values out. I get a positive one and a negative one. And because of that, this would not be a function. Okay, on one like this, if I want to get the y by itself, the first step is going to be to move this 2x. So it's going to become a positive when I move it to the right side to join the 3. And then this 3 is multiplied to the y, so I want to cancel that. Okay, and so now we have the y by itself. And I don't really care about simplification here. The fact that we didn't have to take a square root or a fourth root or anything like that means that this is in fact a function. And in fact, it's a linear function. Okay, we can test for this using the vertical line test. So the vertical line test says an equation specifies a function if each vertical line in the coordinate system passes through at most one point on the graph of the equation. So in other words, if I were to draw a vertical line through the graph, it could only touch, it cannot touch more than one time, is what this is saying. All right, so like looking at this, there is one place where I could draw a vertical line and it would touch it only one time, but there's a lot of places that it would touch more than one time. So all of these is going to touch twice. So that means it's not a function if it touches more than one time. Okay, now this one, even though it goes up and down quite a few times, there's no place that if I draw a vertical line that it's going to touch it more than one time. So this would be an example of yes, it is a function. Okay, we have some vocabulary here, and we've kind of been alluding to these already. So we have input values. The input, what we're putting into the function, those are your x's generally, and that's called your domain values. And your output, that's your y's, and that's going to represent your range. We also refer to the input variables as independent variables because the independent variables are not depending on anything. So the x's really don't depend on anything, but the y's depend on which x value you put into the equation. So that's why the output values are your dependent variables. Okay, so it's important to understand that relationship. Okay, you are going to be asked to find the domain of different functions. So we're going to start with this and we're going to talk about like things that cause us problems when we have an equation like this. So if I have a radical of some kind, particularly an even index is what I'm really referring to here, um, we can't take a square root or a fourth root of a negative number. So for instance, if x was 2, okay, and I put 2 in here, that would be 10 minus 2. That would work fine, okay? But if x happened to be 12, 10 minus 12 would cause me to have the square root of negative 2. Well, I can't do that. Okay, so that means that's not part of the domain. So we don't want to go through and have to check every single number to see which ones work and which ones don't. So what we'll do is we're actually going to take this expression that's under the radical, okay, and we're going to say, okay, we want that to always be greater than or equal to 0, okay? We don't want it to be negative. So if we set up an inequality like this and solve it, that's going to tell us which values will keep this positive, which is what we want to happen. Okay, so I'm going to move this x to the other side. So any number, and this can be written like this as well. I think this is a little easier to understand. Just make sure when you turn it around that it's still pointing to the same thing. So like here it's pointing to the x. Over here it would also be pointing to the x. So any number that's less than or equal to 10 is fine to put into this, okay? Any number that's not less than or equal to 10 is going to cause us to have a negative under the radical and have a problem with it. So this is going to be our domain here, and you can write this either as an inequality, okay, so your inequality is going to look like this, or interval notation, and some of you may be familiar with interval notation. Interval notation, we'll review this a little bit more later, but basically you use brackets, and so like this one, if we're saying less than or equal to 10, and I'm actually going to scrap that, less than or equal to 10 means I'm going to start at negative infinity and I'm going to go to 10, and the 10's included, so I'll put a bracket on that. But negative infinity, I can't ever actually get to negative infinity, so I'm going to put a parenthesis there. So if I actually can get to the number, I put a bracket, and if I can't quite get there, I'll put the parenthesis. Okay, so Another type situation you need to be careful about when you're talking about domain is when you have a denominator. The radicals can cause us a problem, denominators can cause us a problem. So one like this, we have to think about, we can't divide by 0. So if I have any number that looks like this, it's not going to work. Can't divide by 0. If you put it in the calculator, it's going to give you an error. So we want to think like, what number is going to cause the denominator to be 0? So the easiest way to figure that out is just to say, okay, what number causes this expression to be equal to 0? Okay, so we'll set that equal to 0 and solve it, and we see that -3 is the number that if I put it in for x, gives me 0 in the denominator. So that is the number that x cannot be. Okay, so you can either say that x cannot be -3, or if you want to write it in interval notation, you can say -infinity to -3, and then -3 to infinity, because since I don't put brackets on the -3, -3 is not included there. Okay, this one actually combines both a radical and a denominator together. So we're going to kind of combine the two things together. So we've got to think about a couple things. We want to make sure that what's underneath the radical is greater than or equal to 0. Okay, because we can't take the square root of something that's negative. But we also can't have it actually equaling 0, because then the denominator is 0 and we're dividing by 0. So I'm going to take this part off. Okay, so I'm only going to look at x minus 2 is greater than 0. Okay, so any number greater than 2 will be fine to plug into this. It won't cause any problems. Any number that's not greater than 2 could cause problems for us. So like, for instance, 1 is not greater than 2. If I put 1 in, 1 plus 5, the numerator never really causes us problems. The denominator here, 1 minus 2, can't do that because that's going to be the square root of -1. And so 1 would not work plugging it in here. So our domain would be x is greater than 2, or you could write it as 2 to infinity, and we'll put a parenthesis on this one so that it doesn't, because we don't actually include the 2. Okay, this is the easy one. This is a quadratic. I don't have any denominators. I don't have any radicals, so there's really nothing to worry about. So this would be a case of all real numbers would be your domain. Okay, so we're going to say -infinity to +infinity. Right, I've got a couple examples for you to try on your own that are similar. Again, if you want to pause for these, that's fine. And if you want, if you don't want to, that's okay. Okay, so on this one, because it's a radical, I'm going to take what's underneath the radical and I'm going to set that greater than or equal to 0. So I'm going to have 2 is greater than or equal to x. So basically anything that's less than or equal to 2 will work in this, which would be -infinity to 2 with a bracket on it. So that would be my domain, would be from -infinity to 2. Okay, on this one, I have a denominator. So because I have a denominator to work with, I'm going to have to figure out what makes the denominator equal to 0. So I'm going to set x minus 4 equal to 0. So x is going to be equal to 4. So if I put 4 in here, that gives me 0 in the denominator. So that is the number x cannot be. So x cannot be 4. And if I want to write it like this, I can write it like that. Okay, function notation is another thing we're going to be looking at. So with function notation, basically, sometimes we need to work with more than one equation at a time. And so it's kind of a way to give them a name. So instead of saying y is this and y is also this, then we'll say like the function f is this and the function g is this. And that way we can be a little bit more specific which equation we're talking about. Okay. So as far as the notation goes, generally you're going to see me use this, which is F with the parentheses around an X in the place of the Y, and that, so they're basically interchangeable, but that would just denote, so here like f of x is equal to 2x plus 1, so we're just defining what the function f is equal to. And we do read it f of x, okay, that's what how we'll say that. Okay, so let's look at some examples here. When we're asked, we have defined the f and g functions as you see here, and you're asked to find f of 5. So f of 5 just means I'm going to go to the f function and I'm going to put 5 in everywhere that there's an x. Okay, so f of 5 is going to be 2, replace the x with a 5, and then plus 1. So everything that was done to the x here gets done to the 5. Okay, so this would be 2 times 5 is 10, plus 1 would be 11. All right, g of 5. G of 5 tells me that I'm going to go to the g function and I'm going to replace all the x's with a 5. Okay, so I'll have 5 squared plus 2 times 5 minus 3. So 25 plus 10 minus 3 would be 35 minus 2 will be 32. Okay, f of negative 2. So we're going to go back to the f function this time. We're going to replace the x with a negative 2. Be extremely careful with your signs because this is where I see people mess up. So we're going to put a negative 2 here. Okay, so 2 times negative 2 will be negative 4, and then plus 1 will be negative 3. And then g of negative 2, I'm going to go to the g function and replace all the x's with negative 2. So I'm going to have negative 2 squared plus 2 times negative 2 minus 3. So here, if I square a negative, that means I have 2 negatives. Then that's going to become a positive 4. 2 times negative 2 will be a negative 4, and then the minus 3, and so I'm going to get a negative 3 also for my answer on that. Okay, one thing that's important in calculus is something called the difference quotient, and we'll get to why it's important a little bit later. Right now, we really just want to look at it in terms of the function notation itself. So the difference quotient looks like this. It's f of x plus h minus f of x over h, where h is not equal to 0. So we're going to evaluate this with a few different functions and kind of see how this works. And it actually represents the slope of the line between 2 points on the graph of the function. So that's what that's representing. Okay, so if we want to find the difference quotient for this function that's given to us, so we're defining the function f to be 2x plus 1. So I'm going to go up here, and if I look at this, this tells me I'm going to use the f function, and in the place of the x, I don't have a number this time, but I have an x plus h. So this whole thing replaces the x down here. Okay, so I'm going to have 2, instead of x, I'm going to put x plus h, and then the plus 1. Okay, so no longer do I just have x here, now I have x plus h. And then I'm going to subtract from that, always put a set of parentheses here. Okay, and then I'm going to subtract f of x. Well, f of x is 2x plus 1. And then I'm going to divide this all over h. Okay, so that's the substitution part of it. It just depends on what the function is as to what we're going to have to do next. So on this one, we're actually going to distribute the 2. So it's going to be 2x plus 2h plus 1. And then I'm going to distribute this negative. So negative 2x minus 1 over h. Okay, I'm going to go ahead and tell you, if you do this right, everything in this parenthesis is going to have something it pairs with over here to get canceled. Okay, so if that's not happening, you've got some sign errors somewhere, so check for that. Okay, so the 2x's cancel, the 1's cancel. So I have 2h over h. Okay, and now these h's can cancel and leave me with a 2. Okay, this would be a good one to pause and try. Okay. All right, if I'm going to do this one, then this tells me put the x plus h in. So I'm going to have 3, replace the x with x plus h. Still subtract the 5 because that takes care of this function being evaluated at x plus h. And then I'm going to subtract from that, put your parentheses, 3x minus 5 divided by h. Okay, we'll distribute. So 3x plus 3h minus 5. Distribute the negative. Negative 3x plus 5. Okay, and like I said, all of the terms here are going to have a partner that they cancel with. So 3x and 3x, 5 and 5. So I'm left with 3h over h, or 3. So you may have noticed in both of these that we ended up with our answer being the number in front of the x. That is only because these are linear functions, and that pattern will not continue for most other functions. Okay, so on this one, our difference quotient, we're using g's instead of f's. It works the same way. If you want to think of it as an f, that's fine. But looking at this, we have a much more complicated function here. Okay, so the first thing we're going to do is we're going to go and evaluate, excuse me, evaluate the g function by plugging x plus h into it. Okay, so I'm going to take and replace each x with x plus h. So I'm going to have x plus h. So the first x was squared, so I'm going to take x plus h and square that. Plus 2 times, I'm going to put x plus h in for that one as well. And then I've got the minus 3. Okay, I'm going to subtract, and then I'm going to put my parenthesis, and I'm going to put that whole g of x there. Okay, now we're ready to simplify this, and this is where we are going to have a little bit more to do with the simplification. So like this one, I always see people want to say it's x squared plus h squared. It is absolutely not x squared plus h squared. If you come off to the side up here and look at this, if I'm going to square x plus h, I'm going to actually have to fall this out, and I'm going to have a middle term. Okay, so x times x is x squared. If I do the outer, it'll be xh. The inner will also be xh, and then the last is going to be h squared. Okay. All right, so this would be x squared plus 2 of these, so 2xh. And this is where your algebra skills come in. And then plus h squared. So I'm going to replace this with this we came up with here. So x squared plus 2xh plus h squared plus 2x plus 2h, and that's just distributing here, minus 3. And then I'm going to distribute a negative, so minus x squared minus 2x plus 3 all over the h. Okay. All right, like I said before, if you've got your signs right, this whole expression is going to have, each term is going to have a partner that it cancels with. Okay, so there's a positive x squared and a negative x squared. Okay, I've got a positive 2x and a negative 2x. I've got a negative 3 and a positive 3. So what I'm left with is 2xh plus h squared plus 2h over h. All right, we can pretty easily see that there's an h in each one of these terms here. So what we're going to do is we're going to factor out one of those h's. Okay, so if I take the h out as a greatest common factor, if I take the h out here, I'll have 2x. If I take the h out here, I'm going to have just an h. And if I take the h out here, I'm going to have a 2. Okay. All right, so now I can cancel this h and this h. I could not cancel at this point. Okay, I have to pull it out as a greatest common factor. And so then I'm left with 2x plus h plus 2, and that's going to be my final answer. Okay, so when we have a square term, it's definitely going to like up the ante a little bit in terms of how difficult it is, but it doesn't mean it's unreasonable. Okay, this is one I would like for you to try. It's kind of building in in different stages where you culminate in the difference quotient. So just try this on your own, pausing. Okay, so on this one, if you look at it, this notation, it's really important to understand what notation is saying to do. So this is saying go to the f function and replace the x's with an a, okay? So if I do that, I'm going to have an a squared, a minus 4a, and a plus 9. That's all that's telling me to do. Okay, so don't make it harder than it has to be. When I come to b, this is saying use that same f function, but replace every x with an a plus h. Okay, so f of a plus h is going to be, in the place of x, put a plus h. The x was squared, so that means this parenthesis is going to be squared. Minus 4 times, in the place of the x, put another a plus h, and then plus 9. Okay, it would be good to go ahead and simplify this. Okay, so this would be one, because it's squared, it's not a squared plus h squared. It's going to be that where you have to FOIL it out. Okay, so kind of come off to the side, FOIL it out, and it's just like we did before, so I'm not going to go through every step of it. But we're going to end up with a squared plus 2ah plus h squared. Okay, so that's just this part. And then we're going to distribute the negative through. So negative 4a minus 4h, and then plus 9. All right, on part C, we're going to, again, follow what the notation tells me. So we're going to take this f function and plug in a plus h, which is what we just did here. So we don't have to redo it. We can just use that answer there. And then we're going to subtract f of a from that. Well, we already did f of a here. So we're basically going to take our answer from B and subtract our answer from A. Okay. So that's going to be a squared plus 2ah plus h squared minus 4a minus 4h plus 9 minus parentheses a squared minus 4a plus 9. If you don't put this parenthesis here, everybody thinks the negative just goes for the a squared. It goes for that entire term, or that entire expression, and so you need that negative there. All right, so when we distribute that negative, so I'm just recopying here, distribute the negative. Okay, so now we're going to see what cancels. We've got those that cancel. We've got our 4a's that cancel. We've got our 9's that cancel. So we're left with 2ah plus h squared minus 4h. Okay, so that is part C. Part D, we're going to take what we had here. Okay, so that was part C. So I'm going to take that answer, and we're going to divide it by the h. Okay, well, we can't divide it at this point until we factor that h out. So when I take the h out, so I'm going to take an h out of each one of those terms as a greatest common factor. Then at that point, I can cancel those h's, and I'm left with 2a plus h minus 4. And don't try to skip too many steps. Show me the work, because that's important that you're doing that. Okay, so this is calculus for business majors. So we want to tie all of this into the business application side of things. So one thing that you really need to get used to is some of the notation that we use. So the first thing is the cost. Okay, so cost is represented as either capital C or C of X. Okay, and the cost represents, it can be made up of both a fixed cost and a variable cost. So your fixed costs might be like the plant overhead, the design of the product, just the general setup, your advertising, promotions, things of that nature. Variable costs are specific to the number of items that are produced. So the variable costs are always going to have an X beside of it because it's like a per item cost on the variable cost. Okay, so we'll have the fixed cost and we'll add to that the variable cost. Revenue is another important one that you need to know, and that's R or R of X. Revenue is always like it's basically your gross, what you take in. Okay, so if you're selling something at a business, the number of units that you sell times the price that you sold them for is going to give you your revenue. And it's not your profit, it's just revenue. It's how much you take in. Okay, so we always say it's X times P, and this is a lowercase p for price, not profit. Okay, so there is a difference. We just multiply X times P. Okay, a couple things to keep in mind. If your revenue is less than the cost, then the company's losing money. Okay, you would not want that scenario. If the revenue equals the cost, that's where it breaks even. So if you're asked to find a break even point, you find that by setting your revenue equal to your cost. And in a profitable company, the revenue is going to be greater than your cost. Obviously, that's what you would like to see. Okay, capital P is the profit. Profit is what's left over after the bills are paid. Okay, so the revenue is what you take in when you sell stuff. Cost is your expense. So if you take what you take in minus the cost, that leaves you with profit, or the part you get to keep. Okay, so that is an important thing to know. And we already talked about break even points. Okay. All right. So one thing also, a reduction in price usually results in an increase in demand, because if something like goes on sale, then more people are going to buy it and so forth. If the price goes up, then the demand is going to go down. People aren't going to buy it as much. And again, these are generalities, it could be different in certain situations, but that's kind of what we expect to see. Okay, so let's look at this example here. We have what's called our price demand function. So little p represents the price, x is the number of units. So it's basically the price dependent upon the number of units is what a price demand function is. It describes the relationship of the price depending on the demand, which is the x. Okay. The first one, it wants us to determine the revenue function. Well, the revenue is x times lowercase p. Okay, that's going to be x times this. Okay, so x times 1000 minus 5x. We can distribute that, so we'll have 1000x minus 5x squared. So that's going to represent our revenue function. Okay, so that would be our answer for number one. Number two, find the revenue generated if 50 items are sold. So that's going to be R of 50. Okay, so in other words, evaluate the revenue function for x equals 50. So that's going to be 1000 times 50 minus 5 times 50 squared. And that will be 37,500. Okay, so that's not what you profit. That's just what you take in when you sell whatever items these are. Okay, these relationships are very important to know, so just make sure that you are familiar with them. I'm not that concerned at this point that you know like this particular formula and this one. here, but you definitely should know the relationships with these here. Okay, because all of those are very important. All right, our last example here is looking at, it says a company manufactures notebook computers. Its marketing research department has determined that the data is modeled by the price demand function. So again, we have our price model based on the number of units. We want to find the expression representing the company's revenue function and the domain for that particular function. Okay, so revenue, we've said, is the number of units times the price we sell them for. Okay, so that's going to be X. In the place of the price, we're going to substitute this model that we've come up with. Okay, so that's going to be 2000 X minus 60 X squared. Okay, and as far as the domain, our domain was specified up here. So basically the price model only works when we're talking about between 1 and 25,000 units that are being produced. And so the domain is actually going to stay the same for that. And that's all that what we would need to say about that. So it's between, so the domain is between 1 and 25,000. Okay, so same problem here, but we're looking at, we're given the cost, okay? So it says write a profit function. So we figured out what our revenue was on the last slide. So our revenue was, we go back to that, was the 2000x minus 60x squared. Okay, so we're asked to find profit. So profit is simply the revenue, what we take in, minus our expense, which is the cost. So the revenue equation is 2000x minus 60x squared. And the cost, again, when you're subtracting something, always put it in parentheses. The cost is this equation we're given up here. So 4,000 plus 500x. Okay, so we'll simplify this. I do want you to simplify when it's reasonable. I mean, sometimes they're just not reasonable. Okay, so if we combine like terms, we have a negative 60x squared. We would have 2000 minus 500 would be 1500x, and then minus 4,000. Okay, so just to kind of give you a visual of what we're talking about, this is the graph of profit. Okay, so profit, we have what's called our break-even points when the profit is equal to 0 or when the revenue equals the cost. So graphically, these 2 points here are the break-even points, and then this point here would be the maximum profit. Okay, so for whatever reason, we don't really know what the fixed costs are and the variable costs and so forth. There are places here and over here where you're losing money, okay, where the company's not profitable. But as long as you're between this break-even point and this break-even point, you're going to make some profit, with the maximum occurring here at the peak of that profit equation. Okay, that takes us to the end for today. So we'll see you next.